or they will email. Okay, let me share you the slide. How's everyone? Okay. Okay. Can you see the slide? Okay. So this is practical number 1, creating ensemble and multi-class classification. So basically this this tutorial session will show you the example on how we can ensemble the classifier to design a meta classifier, which consists of multiple classifier. Okay, so there are some trying to recall what we have studied yesterday. So basically, ensemble classifier is ensembling a few classifier, whether they are similar type or different type, and these are called the best learner or the best classifier. Okay, so the reason is we want to improve the classification accuracy. So if you look at the diagram here, so this is your original data. So we will partition them into a few partition, and then we will feed them into the multiple classifier. Okay, and then we combine them. So this is the meta classifier. Okay, there are a few techniques on how we can combine them. Okay, the first one is we could take the average. Okay, so let's suppose this is a linear regression. We're trying to predict the numerical values. So what we can do is from each model we can take the summation and take the average, or for the classification, it produced true or false, so we can take the majority voting. Okay, so in this case the voting prediction will be 1, or we could also use the weighted average, in which we put weightage for each of the classifier. Okay, and then when we produce the numerical prediction, we just times the weightage that we have here to produce the weight average prediction. Okay, so there are 3 ways. Okay, this is how we can combine the result from multiple classifier. Okay, but in combining the classifier, we have a few techniques. Yesterday we only talk about stacking and boosting. There are third one called bagging. So bagging consists in fitting several base model. Okay, so the model that you have here will be different. Okay, and you will partition your data into a few groups. So each one of the model here will receive one partition of your data, and then you will combine the prediction here to make the meta classifier. Okay, so the keyword here is that we use the bootstrap, in which we partition the data into multiple partition, and each partition will be fed into different model. So we will have different model here. Okay, so when we compare with the boosting, okay, the boosting will have the initial data, and then you use the model, you use the algorithm to model the data. Okay, so the output of this will be processed or will be considered as input for the next one. Okay, so this is what we did yesterday, where we used the other boost in which each of the incorrectly classified sample will be given higher priority by giving them higher weightage. Okay, so we will go through this until we find the last one. Okay, so each one of the model will be modeled based on the input that you obtain from the previous model. Okay, and third one is stacking, in which you stack all the classifier. This is could be different classifier or same classifier, and you partition your data, and then you get the output to make the meta model or the meta classifier. Okay, okay. For the meta model, train to output prediction based on weak learner prediction. So this is trained to instead of predicting the class here, this meta classifier is to predict the output here. Okay, based on the input that we get from this all classifier. Okay, so having that knowledge, we can summarize that begging. In begging, we're building multiple model from different subsample of the training dataset, in which we use the bootstrap. So always remember, when we say bootstrap, basically we are using different subsample because we partition the data. Okay, for boosting, we are using the same data, but we change the weightage of the sample that we have. Okay, so each iteration, it will learn to fix the prediction error. So how they learn to predict, they will give higher priority to those samples that is incorrectly classified. Okay? And the last one is you building multiple model and the supervisor model that learn how to best combine the prediction of the primary model. So basically this one, we are looking at how do we build a model that can predict the output of the best model. Okay, so this is the start of the practical. Okay, in this exercise, we will use the PIMA diabetes data. So it consists of several independent variables. So for example, the number of pregnancies, BMI, glucose level, skin, age, and so on. So these are the independent variables that we use to model the type of the diabetes that we have. Okay, so before we can start with this, we need to install a few library. So this is the Ensemble library. This is the computer assisted tools. So there are so many functions that we can use here. And also we have this model. No, this is the machine learning called Earth that will build a regression model. Okay, and this is once we install them, then we load them into the memory. Okay, so let me change to RStudio. So you need to install the RStudio when you want to do this exercise. Okay. So first we install this. Can you see my RStudio? Let me make them big. There you go. Okay, so first we install this. Okay, so when you look for this software, this is called R Studio. Okay, so you need to install the R Studio first. You can find them. This is open source, and then we upload them into the memory. Okay, so install, and then you upload them into memory. So we have 3 libraries that we need to install here. So this is the computer assisted tools. Okay, and then we upload them. So if you are familiar with the R Studio, so this is very common, where you install the package first before you can use the function. Okay. So we are done with this. Okay. Okay. In the next slide, we are looking at the library mask. So this is a library that consists of all the function and a sample of data. So we will upload this package. Okay. So if you have any question, you can stop me. Okay. So the data that we are using the diabetes data. So this statement will combine the raw for the training and the testing that we get for the data that we get from the library mass. Okay. So basically we have this. If you want to look at the structure of the PMA, so this is the structure. So we have the number of pregnancy, the glucose level, the BP, skin, BMI, so on. Okay, so what we want to predict is this one. Okay, so this is the data that we have. So we have 532 sample over 8 variables. Okay, and the data that we have is this one, a sample of data. Okay, sample of data. So can you see this one? If you okay, can you type number 1? Okay. So once we combine them, so back to the slide that we have here. So we will split the data, but before we split the data, we set the seed to 502. This means that the random number that will be generated will be the same every time you generate the random number. So this is used whenever you want to repeat the experiment. Okay. So we set seed. Before we can partition the data, we need to upload this library called Carrot. So this is the library that we can use a function called create data partition. So this is the function that we use to split our data. Okay. So we are splitting them based on the dependent variable, and this is the percentage of partition. Okay, and this is not a list, but actually a data, so false. So when we look at the value that we have split, remember that we have how many sample here? So how we have 532. So meaning that they will generate a random number and 75% only. Okay. So you will have a list of index of the data that we have. So this is our data. Okay. So what I will do with this index, I will take 75% of them to be the trend data set. So I will use this statement to create my trend data set. Okay. And the remaining will be used for testing. So look at the command here. So I will use all the row number that stated here to be my trend, and then I will use the remaining because this is basically removing what you have here, and then you get the remaining row. So the remaining row will be used for testing. Okay, so now we have a split data already, trend and testing. Okay, now what we want to do is we want to combine a few classifiers. Okay, before we can combine them, we need to specify how model training is going to be controlled. Okay, so in here we are looking at we are using the cross validation. Okay, 5 cross validation. Okay, so we will only save the final prediction, and we are using the class probability. And if we have imbalanced data, we will resampling up to 5 times for the imbalanced data. Okay, so the sampling will be up to 5 times. Okay, and this is 2 class summary. Okay, because we are looking at the diabetes, no or yes. Okay, so this is how we control the model. Okay, and then now we will train 3 model. Okay, so what happened is we will set sheet number 2 are similar to the previous one. Okay, so we do this one in order because when we do the training and so on, they are randomly generated. Okay, so in this statement, can you see the statement here? Boleh. Okay, so in this model, what we try to model is this one. So basically, we are trying to model the type, which is the dependent variable, based on there is a dot here saying that this is for the remaining independent variable. Okay, so the data that I get is from the trend data set, and the control will be obtained from the previous one where I define here. Okay, and I will use the ROC receiver operating characteristic to measure the quality of the model that we have. Okay, and the list that I have is this one. So we have the regression, we have the Earth. This is the multi-adaptive regression. This is KNN. Okay, so this is my model list. Okay, so the next one is we will look at the correlation between all the model that we have. Okay, so we noticed that the KNN and Earth are highly correlated. So what they say is that we do not want to have the same model that produce the same output. Okay, so if possible, we do not want to have high correlation model together in the same ensemble, because the reason why we form the ensemble is to get different type of model that we have, and then produce different type of they produce the making the prediction differently. So that's why we need more diversity in the ensemble. Okay, but in this case, it's okay. So basically, we are combining, we try to combine three: the regression, the Earth, and also KNN. Okay, but this one is we running them together. Okay, so what it will do here, the second one is I will apply all the model that I have in my list. This is my list, kan? Okay, I will use this model to perform prediction based on the test that we have. And then the type of output will be the probability. Okay, so if I type the model and predict here, so this one will give me no and yes. Okay, for the Earth, the probability of having yes is 0.06. The probability of having no is 0.93. So this is for the first sample only. Okay, so if I go up again here, I have the regression path. The probability of having diabetes yes 0.15, and then this is 0.84. No, this is for the first sample. Okay, so let's remove this no here. So we just have the yes here. So we could perform this one. So this function will be used to only capture the yes column that we have. So now if I look at my ini, so this is, we have three classifier punya result, and this is based on yes only. Okay, so we have three. Okay, now what we want to do is we will transform this one into data frame. Data frame meaning that in table, relational table. So when we try to display them, we will have something like this. So they are nicely arranged here in a table format. Okay. So this is basically the probability of having diabetes. Okay. For each of the classifier here. Okay. Now, what I want to do is, okay, what if I combine all of them? Okay, so I will use the stack method in order to combine them. Okay, so can you see the slide? Okay, so what we have at the moment is up to here. If you okay, can you type number 21? Okay, type 21. Okay, so what we have at the moment is my the classifier 1, classifier 2, classifier 3. Okay, so what we want to do is we want to form the classifier number 4, which combine the predicted probabilities from all those three. Okay, so how can we do that? So we use the stack method, the caret stack method. So basically it will take all the model that we have in the list of model. Okay, we put them in the stack, and then the method is GLM because we are looking at the numerical value. We want to predict the probabilities of having diabetes. And we use the ROC in order to measure the quality. Okay. And the training control will be this one. We will use the bootstrap five times, and we save the prediction, only the final one. And then we use the class probability. and this is the two-class summary. Okay, so if I copy this one, basically I am creating the fourth classifier. Okay, the stack now is the fourth classifier that combine the three. Okay, so if I look at the summary of the stack, okay, based on here, so if we see 3-star or 2-star, they are significant, important in contributing to the modeling of the prediction. Okay, so it's okay to have both of them here because they are both significant. Okay, so as long as you have 1-star or 2-star or 3-star, they are very significant. Okay. Okay, now we will compare the performance of this stack, the fourth classifier, with the three model that we have. Okay, so this is basically compute area under the curve of the ROC. So the first one, okay, this one will perform the prediction using the ensemble. This is our test data, and we are using the type of probability. So the range of value will be around 0 and 1. Okay, so we assign this probability to the ensemble in this model, and that's why we have the fourth one here. So this is the area under the curve, showing that, okay, in this example, the ensemble performance is comparable to the Earth algorithm. Okay, so if you run your program, you may have different accuracy here, but this is more on the performance. This is not accuracy, but they measure the performance of the classifier based on the receiver operator characteristic. Okay, those who have learned machine learning, data mining, you have covered that ROC. Okay, area under the curve. Okay, so what can I say here? When you use ensemble classifier, you definitely will have better accuracy compared to the single one. But in some cases, single classifier outperform the ensemble. Okay, but in order to get higher accuracy, it's better to use ensemble. So over here we can tell that the ensemble produce better. Okay, so this is just a simple exercise. So in your exercise later on, okay, you'll be asked to perform the same thing, but you will be using different classifier. Okay, and what I suggest is I will share the slide so you can go through the sample, this sample coding, and then you later on when you try to answer what the actual practical asks you to do, then you can modify your coding based on the requirement of the exercise later on. Okay, so this is just a simple one. Okay. So do you have any question? Okay, in this slide, see, every time we run the model, it will give you different accuracy. Okay, so it's better to run your experiment 10 times, and then based on the result, you can do the t-test to validate the significance of improvement of your ensemble technique. Okay, so we will start the second part of the practical. Okay, the second practical dealing with text mining, topic modeling. So this one we run through the exercise together with the cybersecurity when we have a training, cybersecurity Malaysia. So we train the people on how do we perform topic modeling based on the news, based on what people say, and so on. Okay. So before we continue with the practical number 2, let me prepare that one first. I will. We have the slide, but I need to prepare the text of the data set that we'll be using. Okay, give me 5 minutes. Okay, let's start with the second practical. The second test data. Okay, let me share the slide first. Okay, can you see the slide? Boleh? Boleh ya? Okay. So this is a simple text mining exercise in which you will see how we clean the data, how do we perform the topic modeling. Okay, although the topic modeling that we use, the algorithm that we use is called LDA. Basically, this is one of the technique that we use for topic modeling. So what is topic modeling? We are looking at a few documents, and then we will group this document based on a particular topic. Okay, so they will automatically assign the document to the right topic. Okay, so that is what we call topic modeling. We are trying to figure out the topic of that particular document by assigning them into the group of document in the same topic. Okay, so let's take a look at here. So you have studied how to construct a document term matrix. Okay, so these are some of the pre-processing. So we change the capital letter to lowercase, we remove number, we remove punctuation, we remove stop words, we remove excess white space, word stemming, word replacement. So these are some of the most common and useful transformation of text file that we have. Okay. And what we wanted to do is we want to transform the document into a vector space representation, term document matrix. So this is what you have been learning so far. So you learn how to construct the TF-IDF matrix. Okay. And based on the vector space representation, we can perform some of the analysis. This is some of the quantitative analysis of the text that we have. We can perform sentiment analysis. We can perform complexity analysis. We can also perform the formality analysis, diversity, and dispersion. How would spread throughout a document and serve as an excellent way to explore a text and identify pattern. Okay, so if you are interested in doing some of your FYP for some of these, so this is a very interesting area. Most of the work has been done in English, but not in Malay. Okay, so what we could do is we look at the model that we have for English language, and then we apply the same model to Malay with some adjustment in order to accommodate quantitative analysis of Malay language document. Okay, and one of the analysis that we can do is we can perform topic modeling. So topic models are a powerful method to group document by their main topic. So basically, in topic modeling, we allow probabilistic modeling of term frequency occurrence in document. So we're just counting the number of time the term exists, and we compute the probability of the term. Then we can use that one in order to perform topic modeling. Okay, the fitted model can be used to estimate the similarity between documents. So we can use the TF-IDF matrix in order to compare the similarity of the document by using the cosine function. So all of you have studied the cosine function. One of the technique that we use is called latent direct slit allocation, LDA, with Gibbs sampling. So this is, in short notation, we use LDA for topic modeling. So basically what it will do is we have topic. Okay, so each topic will have their own keyword. Okay, and what it will do, it will try to map the document to match the most number of words in each topic. Okay, so for example, we have yellow, pink, green, and blue. So each one of these group will have their own keyword. Okay, so the probability of the word can be used in order to match the topic that we have. So that is the basic description of LDA. It will take the word in each document, and it will map to the word that exists in each of the existing topic that we have. Okay, and this number is basically the probability of having that word in that particular document. So that in order to the topic. Okay. Okay. The exercise to build topic model on the 6 state of the United States. So I have 6 pictures from President Obama campaign. So we want to see the content of the speech that they have, whether they are talking about the same thing or different from each other. So we have 6 samples of speeches we want to analyze. Okay, whether they are talking about the same topic or different topic. So we will group them into the different topic. Okay, And these are some of the packages that you need to have. So we install package, the text mining TM, and then upload. We also have the wood cloud that will visualize your text based on the number of woods. So the most frequent wood will appear bigger in your visualization. Okay, and then we have the raw color viewer. So this is used in visualizing another diagram. Okay, and we have this topic model. So this is where we get the LDA. Okay, now let me bring you to the R software so that you can see in live. So what happened? So we install this. But this exercise, we run this one through few years back. Hopefully it's still valid because it depends on the version number of the R software that we have. Okay, first we install the package Turing machine, not Turing machine, text mining. Can you see the R Studio? If you're okay, can you type number 8 3 times? You write number 8 3 times. Okay. So in the text mining, we have the natural language processing. We have so many packages that we can use. It takes some time. Hopefully there is no error. But last time when we ran through this exercise, there was no error. Okay. So we upload this one. Oh, not installed, already installed. Okay. Okay, and then we upload. And then the wood cloud. Okay. Then we upload. We install again. This. Okay, so all of this library will be uploaded. So topic modeling, text mining. So we have 3 library that actually 4. The wood cloud is used to visualize your text later on. Okay, so we are done with this. Okay, next one, we will see. Okay, so we get the data from our Active Directory. So how do we set the working directory? So we will say, this is my working directory. So this is where I keep all my data. If you look at my data here, so I am in the test and data. So we have this 6 6 document. Okay, no, 7 document. Okay, so once I set the working directory, and then if I try to extract the name, okay, so if I look at the number of file that I have in that directory is 7. So basically, I'm checking the number of file that I have in my directory, which is equivalent to test data. Okay. So if I try to list all the file that I have in my directory, so these are all the 7 files. So I will get these 7 files, and then I will use the LDA to perform the topic modeling that we have. Okay. So before that, what I will do, I will get all the file, and then I will convert them into corpus. Okay, so the difference between this document text and corpus is that I will compile all this text file to become one set of document. It's called corpus. Okay, so if I try to type document here, it says I have 7 documents in my corpus docs. This is a set of document. Okay, now for the set of document, I can perform all this. I change the capital letter to lower, okay, and then I can also remove numbers. Okay, so and then I can also remove punctuation, and then I can also remove the stopword. Okay, and I also can remove the extra white spaces that we have. Okay, and also I could remove some of the word that is not considered stopword, but meaningless. Okay, like can, will, that, don't, and so on. Okay, you can add the list. Okay, okay, so if I try to, okay, this one will be converted to, oh, I need to change this one to plain text first. Then I can convert them into document term matrix. Okay, so in that, if you look at the dimension of the document term matrix, so basically I have 7 document and 4,715 terms. So you just imagine you have 7 document and 4,715 unique terms. Okay. Okay. So we could use, if you look at the slide here, we have so many terms that we have, 4,700. Okay, what we can do is we can remove the sparse term with the remove sparse term function, okay, using a number between 0 and 1. So what it means that if we have 0.75, so if we say the sparsity threshold is 0.75, it would be 1 minus 0.75 times 7, which is equal to 1.75. So meaning any term in fewer than two document would be removed. So that means any term that exists in less than 2 document, they will be removed. So this is to reduce the number of term that we have. So remember that in the last lecture we mentioned about feature selection. and we are looking at the threshold of the TF-IDF weightage. Okay, so this is one of the way on how we can remove the features which are which consider less frequent. Okay, so how do we remove them? So we just take the, the document term matrix and we say remove sparse term 0.75. Okay, so if we look at the dimension of the new document term matrix, it will be less number of features. So any any term that exists less than 2 documents, it will be removed. So if they exist one time, they will be removed. Okay. So this is more on preparation. We are looking at, because we have 7 here, okay, 7 row. Okay, so we want to rename them. The row name will be 10, 11, 12, 13, 14, 15, and 16. Because we have, based on this data, we have 7 rows of document. So we will name the row name. The first one will be the speech in 2010 up to 2016. Okay. So if we look at the theme, so we still have 7 documents, but the row name will be there. Okay. Okay. If we inspect the content of the document for the first 5 terms, this is what we get. So document 1, 2010 will have for the 5 term we have 0, 1, 1, 2. Okay, meaning that the ability exists in that document and also in 2013 document and so on. Okay. Okay, now we want to we can move on to exploring word frequency by creating an object with the column sum. So basically we are looking at the number of time that term exists in all documents. Okay, so we can use the column sum in order to sum up the number of occurrence. Okay, so in here what we have is individual document. So if we want to sum up the number of times that term exists, we could use the column sum. Okay. So we use the column sum in order to sum up the number of times each term exists in all of the document, and then we will order them using the decreasing order, because minus. Okay, and this is what you get. Okay, so that means the term new exists 193 times in 7 documents. Okay, if you want to look at the tail, so you just look at the tail here. Okay, so 0, youngstown, youngest, year old will be 2 times only. So this is the minimum number of occurrence, because remember just now we remove sparsity by 0.75. Okay, so any term that exists one time only will be removed. Okay. Okay. Now, okay, now we have to further reduce the number of term that we have, because all this year, all and so on. This one, two times only. So what we want to do is, if you look at this slide, we can use the find frequent term. We can see which would occur at least 1 to 5 times. Okay, so if we use the this one, find frequent term, so this American, all of these occur more than 1 to 5 times. Okay. And also we can also look at the correlation between each term that we have. For example, jobs here will be associated with another term at least having correlation 0.85. So meaning that jobs and college and jobs and serve market and so on, they have at least correlation value 0.7, 0.85. So this is how we can extract some of the value that we have in our document. This is the frequent term, and this is we're trying to find the associate. Okay, so we could also use different things like jobs. Maybe we use defense and at least 90. So we have costs already, education, part, study, and so on. Okay. Okay, now we can also visualize the content of the document using this. So, could not find function word cloud. Okay, let's, maybe something wrong with the library. Okay, let's install again the word cloud. And upload them. Okay, now we can this is our word cloud. Okay, so you can see from the word cloud here, America, jobs, works all appear more than the other term. Okay, so more than the other term, America, job, tonight. So meaning that you can use the word cloud in order to highlight which words are mostly used in the document. Okay. Okay. We could also use this command to show the word that is frequent at least 25 times. So this, all of this, having the frequency at least 25 times. Okay. Okay. The following statement will be used to produce a bar chart for the 10 most frequent words. Okay. So what we do here, we will let me reduce this. Okay. We are looking at the column sum of the document term matrix, and we are looking at in decreasing order. Okay, sort them. Okay, and then we convert them into data frame, and then this is all the words that we have. We extract them, only 10 of them. Okay, so this one refers to column number 1 up to 10. Yeah. Okay, and we produce this one. So this is the, we redraw that one. Okay. Basically, we don't have enough space, but can you see the name? So I need to reduce this one to zoom view, zoom out. Okay, view, zoom out. Okay, so these are the 10 terms that we have. The top 10 used in the speech for the 7 speech that we have. Okay. Okay, now the last one is we want to perform the topic sampling. So we will use this statement. Let's zoom in so that you can see the command. Okay, we set seed and then we will apply the Gibbs method for the LDA. So we are saying that we divide them into 3 groups, k equal to 3. Okay, and we are looking at, okay, now we want to look at the topic. Okay, so what we have here is that in 2016, the content of the speech is similar to the one in 2010. And then the content of the document for 2014 and 2015 are the same. And then in 2011 and 12 and 13, they are the same. Okay, so this is how we prepare the document, and then how do we perform the topic modeling based on the content of the document. So it is very, what if we put 2 here or 4? Okay, so we will have different result. Okay, so by increasing the number of k, we can differentiate the content of the document. Okay, in the previous one we say, okay, in 2011 and 2013 they are the same, but now if we split them into a smaller group by increasing k, so basically these 2 are the same, and then these 2 are the same, and then these 2 are the same. Okay, so that's it about the topic modeling. Very interesting because all this time you learn about the theory, about how to construct the TF-IDF, you penat kira, all those things, and then you compare. So when you look at the application of all those methods that you have studied, this is the one of the application that we can use for topic modeling. Okay, so very simple. We just type a few statements for you to execute, and then you get the result. Okay. So with that, we finish this one. You have 2 practical that you need to complete. Perhaps I can give you 2 weeks to complete the practical. But it will be very easy because you just follow through the slide. But the question asked will test how well you understand the practical. Okay, so it will be due after Chinese New Year, Friday. Okay, any question?